Hello, welcome to My Easy Statistics. Please like, share and subscribe the channel. Contact me for data analysis and training. You can contact me through email or WhatsApp. Hierarchical Log Linear Analysis. Hierarchical Log Linear Analysis is a technique used for examining relationship in a multi-way table by modeling the logarithm of expected cell frequency as a linear combination of factors and their interaction. This method helps identify the significant interaction between categorical variables. When we have two categorical variables and we want to know the relationship between these two categorical variables, we can do cross table and we can do chi-square test to know whether there is a significant relationship between these two categorical variables or not. But when you have higher order of interactions, like you have three categorical variables and you want to know whether the interaction of these three categorical variables is significant or not, then we must do this hierarchical log linear analysis. We'll take one example and discuss this hierarchical log linear analysis in a simple and easy way. In this example, we have three categorical variables: gender, smoking and disease. Now you can see gender has two levels, like male and female, and smoking is also two levels, whether they are smoking or non-smokers, and disease also two levels, where they have a disease or they don't have a disease. We want to find what is the relationship between gender, smoking and a disease. To know this relationship, we are going to do hierarchical log linear analysis. First, I am going to create a contingency table for these three levels. Next, I am going to do this log linear analysis, and you can see the data is in a form of frequencies. Okay, so for making this analysis, first you must go to data and make weight cases. Now in this case, you must take weight cases as frequencies, okay, and click OK. Now let us create a table, contingency table for these three levels. For that purpose, you must go to Analyze, Descriptive Statistics, in this cross tabulations. In this, first we want to take gender wise, so make it as a layer. We want disease as a columns and smoking as a rows, okay, and click OK. Now we are going to get total data sample size is 456. In the case process summary, we can see the total sample is 456, and you can see gender wise, within that smokers, non-smokers, smokers, and within that we can get the diseases wise. So this is the cross tabulation between smoking, disease and gender. Now we will do this hierarchical log linear analysis. For doing this log linear analysis, we must go to Analyze, in that log linear, in this model summary. Now take all the three categorical variable, gender, smoking and disease. Now define the ranges for them. Since all the three are having same range of 0 to 1, I am selecting all together and defining the range. If you have different ranges, you must select each variable and do the range selection. So here define range 0, minimum, maximum 1, click continue. Now you can see here in this we are using backward elimination. What is meaning of backward elimination? Means we are trying to understand the interaction between the categorical variables. So first it takes a higher order of interaction, that is three levels, because we have gender, smoking and disease. So system will take the higher order. It takes gender into smoking into disease, the first order. If it is not significant, then system is going to check the next two order. Two order means gender into smoking first it checks, then gender into disease and smoking into disease. In this way it goes from higher order, that is three-way interaction to two-way interaction, and after that it checks the main interaction. So this is called backward elimination method. If you want to go with a single step also we can do it, but here we do with backward elimination. Now let us click on the options. In the options, you can select this parameter estimations, association table, and important thing is that this delta we don't need to add in the table 0.5. We want to just get the exact value, so I'm making it as 0. Click continue and click OK. Once I click OK, we will go to the output screen. This is the output for hierarchical log linear analysis. First we got warning. The warning says that the delta is made as 0.0 because from 0.5 we have changed it to 0.0. So this information we got. Next one is a data information. It says that total sample we have 456 and categories wise gender has 2 levels, smoking has 2 levels and disease has 2 levels. Next one is design one, converging information. This table presents the convergence information for a statistical model that analyzes the relationship between the 3 variables gender, smoking and disease. The model that includes the interaction of gender, smoking and disease converges successfully after just one iteration. The perfect fit, maximum difference of 0.000 between the observed and fitted marginal indicates an excellent model fit, suggesting that the model accurately presents a relationship among the variables in the data. The convergence criteria was 0.250, and since the actual difference was much lower, this further confirms that the model has achieved a satisfactory solution. Now, after this convergent information of one iteration where we have gender into smoking into disease, we got this cell count. Now, this is same as the cross table which we have seen. Next is we need to discuss about goodness of fit test. In this goodness of fit table, we have likelihood ratio and PSN both are significant, that is less than 0.05. we got dot in this case. A dot means it is 0.00. if it is less than 0.05, it means there is a significant difference between observed and expected frequency. So this is called goodness of fit, means the model is not fitting the data. This is important to understand. The model is not fitting the data. There is a difference between expected frequency and observed frequency. Next we will discuss about this K-way and higher order effects. Now you can see we have 2 tables here, K-way and higher order effect. Next one is only K-way effects. K-way is number of dimensions. Now if you see K is equal to 1 means a main effect, like we have gender, disease and smoking. This is significant. Their effects are significant. If you see 2, K is equal to means a two-way interaction, like gender into smoking, smoking into disease. This is called two-way interaction. They are also significant. Okay. And coming to the next one, K-way and higher order, for K is equal to 3, that is 3-way interaction. This is not significant. The significant value we got is 0.111. which is more than 0.05. So the 3-way interaction is not significant. This is same for even K-way effect and K-way and higher order effect also. It means to say main effect is significant, 2-way interaction is significant, but the 3-way interaction is not significant. This is very important point. We don't have interaction of gender into smoking into disease. So only 2-way interactions are significant. Let us see that in the partial association. Since we now came to know that 2-way interaction is significant, now let us see which 2-way interaction is significant. You can see in partial association, gender into smoking, this is significant. Gender into disease, this is also significant. And smoking into disease also significant. If the significant value is less than 0.05, we say it is significant. But you see the main effect, gender is 0.454, which is not significant. Smoking main effect is significant and disease is not significant, 0.261. These two things are not significant. That is the main effects, gender and disease is not significant. Now till now what we have come to know is three-way interaction is not significant, all three two-way interactions are significant. These two-way interactions, all the three are significant. And in the main effects, gender is not significant and disease is not significant. Now coming to parameter estimations. Now in these parameter estimations, we are going to see which is most significant, which is more significant. We can see here the significant values. Now already we have come to know that the three-way interaction is not significant. Okay. Apart from that, you can see, okay, all are having significant. And in this, which is most significant, you can see the estimation values. Okay. Gender into smoking is the highest impacting, followed by smoking into disease. These combinations are very effective. Gender into smoking, it's very effective. If you see the cross table, understand whether males are smoking more or females are smoking more. That interaction we can understand. That is very effective. And next is smoking and disease is also very effective. It means people who are smoking may be having more diseases. So that we need to check in the cross table. We can do chi-square test and we can even get the effects also. How effective is that relationship? But we can see the other things. Gender into disease. This is also significant but not so much significant. You see the estimation which is having the highest value, that is more effective. This is called parameter estimation. From this table we come to understand that the three-way interaction is not significant. Apart from the other interactions, the two-way interactions and main effects are significant. And we can know how much effect they are from the estimation value, or we can even come to know from the z values also, we can know that values. Now coming to the next one is backward elimination statistics. This is important. Now already we discussed this. Backward elimination means system starts with the higher order of interaction, three-way interaction first. If three-way interaction is significant, system will stop there. It will not come further analysis. If three-way interaction is not significant, then system will discuss two-way interactions. In two-way interactions, if any two-way interaction is not significant, then it will discuss the main effects. But in case if the higher order is significant, system will stop there and it will not do further analysis. And you can clearly see that in step summary. You can see three-way interaction, gender into smoking into disease. See the significant value 0.103, which is greater than 0.05. So this is not significant. It means three-way interaction is not significant. Then system starts doing two-way interactions. You can see in step 1, it does gender into smoking. This is significant. And gender into disease. This is also significant. Smoking into disease. This is also significant. So it has tested, once the three-way interaction is not significant, it has tested the two-way interactions. If in case the three-way interaction is significant, then it will not do two-way interaction. It takes granted that, okay, two-way interaction also will be significant. Since three-way interaction is not significant, it has did two-way interaction and found that they are significant. Now this is all called backward elimination. And after that, again we come to convergent information. Converging information, this gives the information about only two-way. You can see here there is no three-way interaction, only we have two-way interaction, that is gender into smoking, gender into disease, smoking into disease. The final model after backward elimination includes a significant two-way interactions without the three-way interactions, which was not significant. The model converges effectively, requiring no further iteration, and the fit of the model to the data is good, with a maximum difference of 0.118 between observed and expected frequency, well within the acceptable convergent criteria of 0.250. This implies that the simplified model adequately captures the relationship in the data without overfitting. Next, cell count and residuals. This is same as what we have seen the cross tables between the three dimensions. The last one is goodness of fit. The goodness of fit table provides the measure of assessment how well the final model fits the observed data. Both goodness of fit, that is likelihood ratio, and Pearson chi-square indicates that the final model adequately fits the observed data. The higher p-value, that is more than 0.05, here we got for likelihood ratio 0.103, and for Pearson we got 0.111, which is more than 0.05, means that there is no significant difference between observed and expected frequency, suggesting that the final model is appropriate for the data. This implies that the model, which includes a significant two-way interactions, capture the underlying structure of the data effectively without overfitting. So this is the end of the analysis. So in the total analysis, system first did three-way interaction. That is not significant. So it found two-way interaction. Two-way interaction is significant. It did the model fit and said at the end that there is no significant difference between observed and the expected frequency. That's the final goodness of fit test. This is significant.